to deal with analytical limits at infinity, there's a big idea that I need to use. The limit as x approaches infinity of 1 over x is like asking the question, what is 1 over a huge number going to get really close to? What do you think? Any ideas? Well, if you go to the calculator and try 1 over a million, 1 over a billion, 1 over a trillion, those answers are getting really, really, really small, really close to 0. This limit is going to equal 0. I guess in the same breath, we should also take a look at the limit as x approaches negative infinity of 1 over x. What do you think that's going to be? What's the limit as x approaches negative infinity of 1 over x? What's 1 over a huge negative number? For similar logic as this one's also going to be 0. I promise these get a little bit more involved than just that. But let me show you what we can do with this. Let's take a look at the limit as x approaches infinity of 4 minus 1 over x plus 2 over x squared. Okay, well, if you plug a huge number into the constant 4, there's no place to plug in that huge number. You're just going to get 4 out of that. Minus 1 over a huge number. Well, what's 1 over a huge number? 1 over a huge number? 0. Plus 2 over huge number squared. Well, a huge number squared is an even bigger number. So 2 over an even bigger number, still just going to be 0. 4 minus 0 plus 0, we're going to get 4 for that limit. Next, let's take a look at the limit as x approaches infinity of 2x plus 1 over x plus 1. If you try to plug in a huge number, we actually have a problem here, because the top is a huge number and the bottom is a huge number. I actually get something in the form infinity over infinity, and I call this an indeterminate form, which just means if you get that, well, we don't really know what the answer is going to be. The answer could be 0, could be 5, could be -3, could be infinity, could be does not exist. We've seen another indeterminate form, actually, 0 over 0. We saw that sometimes that's 0, sometimes it's 4, -3. Many things can happen from there. Okay. There's a trick we're going to use. And just go with me for right now on this. I'm going to show you a shortcut in a little bit. But the trick is, I'm going to divide the numerator and the denominator by x. I'm going to turn this problem into the limit as x approaches infinity of 2x plus 1 divided by x over x plus 1 divided by x. When you do that, you're going to get the limit as x approaches infinity of 2x divided by x is 2. Plus 1 divided by x, I'm just going to write that as 1 over x. In the bottom, x divided by x is 1. 1 divided by x is 1 over x, so I'm going to get something like this. Now, I can go and take my limit as x approaches infinity. I can go and plug in a huge number. I'm going to get 2 plus, what's 1 over a huge number? 0. On the bottom, 1 plus, what's 1 over a huge number? 0. You're going to get 2 over 1. You're going to get 2. One quick thing about notation. You are not allowed to plug in infinity as if it was a number. So what I'm not okay with you showing is 2 plus 1 over infinity over 1 plus 1 over infinity. That's not valid notation, not accepted on the AP exam, wouldn't be accepted in college. If you feel like you can't go directly from here to here, what would be okay, if you want to show a little more work, you could say 2 plus 1 over a huge number. That's actually okay, but you just can't plug in infinity as if it was a number. So please do not do that. That is one of the notation things that I will be looking for on tests and quizzes, and you will lose some points if you're plugging in infinity like it was a number. Okay, I'd like to take a look at 3 related problems. I'd like to do the limit as x approaches infinity of 2x plus 5 over 3x squared plus 1. Then I'd like to do the limit as x approaches infinity of 2x squared plus 5 over 3x squared plus 1. And finally, I'd like to do the limit as x approaches infinity of 2x cubed plus 5 over 3x squared plus 1. All of these are that indeterminate form of infinity over infinity. Usually these problems are going to be that indeterminate form, so we have some simplifying to do. Our trick, which actually isn't really going to matter after these 3 examples when I show you a shortcut, but our trick is always going to be, when the top and bottom are polynomials, to divide the numerator and denominator by x raised to the highest power in the denominator. All of these have an x squared as the highest power in the denominator, so I'm going to divide the top and bottom by x squared. If you're watching this on YouTube, push pause and see what you can do. If you're watching this in Edpuzzle, it will just stop. Take a moment and just do the simplifying and then stop. Okay, so I need to divide everything by x squared. This first one is going to become the limit as x approaches infinity of 2x over x squared, that's 2 over x, plus 5 over x squared, the denominator is 3, plus 1 over x squared, and the rest are all going to look fairly similar. We're going to get the limit as x approaches infinity of 2 plus 5 over x squared over 3 plus 1 over x squared. And the last one is going to give us the limit as x approaches infinity of 2x plus 5 over x squared all over 3 plus 1 over x squared. Well, now that we've rewritten it, what's that first one going to be when you actually take the limit? I'm going to go and plug in a huge number. 2 over a huge number, 0. 5 over a huge number, 0. On the bottom, 3 plus 1 over a huge number, 0. We're going to get 0 over 3. That limit is 0. See if you can do the second one. This is going to give me 2 plus 5 over a huge number is 0. Over 3 plus 1 over a huge number, that's also 0. And we're going to get 2/3. See what you can do with that last one. It's a little different. Well, up top, I'm going to get 2 times a huge number plus 5 over a huge number, that's 0. In the bottom, I get 3 plus 1 over a huge number, that's 0. Well, 2 times a huge number is a huge number. Divide a huge number by 3, it's still a really big number. We're going to get infinity over here for our final answer. Remember what I said about you can't plug in infinity. However, infinity is a valid final answer. And actually, there are 3 different things that could happen here. We could get 0, we could get infinity, or I suppose negative infinity, or we could get, well, some other random real number. What I want you to notice about this is when we did all this dividing work and stuff, everything but the leading term on the top and bottom didn't matter. Those pieces just gave me zeros. I really just need to focus on my leading terms. And actually, this is a shortcut that we're going to use to evaluate limits at infinity, as long as the top and bottom of our fractions are polynomials. If they're not, all bets are off. Okay, so here's our shortcut. For evaluating limits at infinity, for rational functions. And the definition of a rational function, top and bottom, are polynomials. That was a big title. Because all we care about are the leading terms, we're just going to rewrite our limit as the ratio of the leading terms, simplify, and evaluate. We are going to rewrite as the limit of the ratio of the leading terms we are then going to simplify and evaluate. We're going to rewrite as the limit of the ratio of the leading terms. We're going to simplify and evaluate. The limit as x approaches infinity of 5x cubed plus 1 over 10x cubed minus 3x squared plus 7. According to my new shortcut, I can rewrite this as the limit as x approaches infinity of, I'm just going to focus on those leading terms, 5x cubed over 10x cubed. I'm going to simplify. I can cross out the x cubes. I can get the limit as x approaches infinity of 5 over 10. There's no place to plug in our huge number. We're just going to get 5 over 10, but please don't call it that. Call it 1/2. Let me see if you can try the next two. The limit as x approaches negative infinity of 2x to the 10th minus 1 over 10x to the 11th minus 3. See what you can do. Going to do some simplifying over here. 2x to the 10th over 10x to the 11th. But by the way, make sure you're writing your limits because I haven't yet evaluated, done any plugging in of a huge number or anything like that. I'm going to get the limit as x approaches negative infinity of 1 over 5x. 5 times a negative huge number is a negative huge number in the bottom. 1 over a negative huge number is going to give me 0. One more for you to try. Let's see what you can do with the limit as x approaches, what do I want to do here? As x approaches negative infinity of negative 3x to the 12th plus 2x over x to the 11th minus 2x to the 4th. See what you can do. Well, negative 3 times a negative huge number is going to give you a positive huge number. Huge number over 1 is a huge number. Your answer is infinity. If you feel like you needed to show a little more work, remember you could say negative 3 times a negative huge number. Just don't say negative infinity and the plugging in, and you'll end up with positive infinity for your answer.